Yeah, I'll just go ahead and get started here, and I'm sure people will file in, but the first minute of a presentation, how much are you really missing? Okay, so code is communication. This is a presentation I've been wanting to give for a little while now about. I think that there are things about legacy code that a lot of people tend to overlook, and we're going to talk about that today. And thank you to Corgi Bytes for giving me the chance to chat about this up here. I do work at Corgi Bytes. I'm a lead code whisperer. And before that, I worked in mobile software at a startup located in Central Illinois, where I still am to this day, although a little bit different of a location. Before that, I used to be a nuclear electrician in the Navy on a submarine, which was interesting, but very different from what I'm doing now. But it did give me an appreciation for maintenance, which kind of brought me to Corgi Bytes. So let's just get into it. Let's get to the good stuff. If this will advance. Okay, fantastic. Okay, so this is one of my favorite quotes about computer science, just generally speaking. And I think it's very relevant for what we're going to be talking about today, which is that the quote is, programs must be written for people to read and only incidentally for machines to execute. And this is from the, what some people would call the computer science Bible, Structure and Interpretation of Computer Programs. And this is really interesting because computers, in their argument, sort of exist as this like neat tool to execute code. But that's really not the focus of what writing code is all about. You're really formalizing, and writing code forces you to formalize your thoughts about how a certain process should behave, and making that formalized process, formalized code, readable and usable for other humans takes precedent over the fact that computers can, as it so happens, execute it flawlessly every single time. So keep that in mind as we're going forward here. A little bit of a preview of what we're going to be talking about today. We're going to go over some case studies. I've got 3 case studies for you today that I'm actually very excited to talk about because I think they're all very interesting. We're going to then talk a little bit about, why did this happen? Why do people do these rewrites despite what happened, which we'll see here in a minute. And I'll transition from that into making the case for a little more respect or appreciation for the value that already exists in what some people would call legacy code. And as a bit of guidance for people that are looking to do some refactoring, some rewriting of their legacy code, I'll talk a little bit about how equivalence, in computer science terms, gives us some indication of how to do that safely or more effectively. Let's get right into it. Let's talk about some case studies. And this one's one of my favorites. It's the YOLO rewrite that Uber engaged in. I'm going to assume most of you are familiar with Uber. Just broadly speaking, it's a taxi technology company that allows people that want to drive with people that want to be driven. And they got up on stage, or their CEO got up on stage during an internal conference and said, within the year, we will have a brand new application on iOS. Well, what was the state of the application prior to this proclamation? Well, to hear them describe it, they were constantly deploying hot fixes and just burning releases, like releases that were either not good. They had issues that were only detected in production, or releases that they had to replace right away. So there was precedent for them to do something. And about this time, for those of you who might have been in the iOS development space, Apple announced a brand new programming language called Swift. Now, Objective-C is what was being used previously to write iOS applications. And Objective-C, there's some good to it, don't get me wrong, but the syntax is very weird, and it's very easy to do things that are going to behave not how you expect them in production due to nil messaging and things like that. So Objective-C has been around for a very long time. It was founded during Next Step, It was a product of Next Step while Steve Jobs was working there. And then it kind of got brought back in-house in Apple when Steve Jobs came back. So, it's an older language, and I think you could make the case that since Objective-C was released, in general, computer science has learned a lot about programming language design. And so Swift was very, very appealing. I know when I first started working in Swift, I liked it a lot. It had a lot of stuff for, making variables immutable, structs and things like that. Stuff that just really didn't exist in Objective-C. And so it was very appealing to them. So Uber did what you might expect. They created a small skunkworks sort of project and just investigated, is Swift a good fit for what we're doing here at Uber? And can we write the application that already exists in this entirely new framework, language, paradigm, whatever you want to say? It's a big change from Objective-C. And you might be asking, well, maybe they could have done this migration more gradually. They certainly could have. They did not. And I think part of that was just because they thought they would get better results switching entirely to Swift. So that original trial of Swift worked very, very well. The developers working on the project liked it a lot. It looked like it was going to be a good fit. And so the company as a whole just went ahead and greenlit the development. But the wheels started falling off pretty quickly. One example, and I've experienced this personally, is that if you're writing Swift, you're almost always going to be using Apple's IDE, and that's Xcode. And Xcode had some, let's say, issues, broadly speaking, working with Swift. And so they related a case where at one point they would try to write a line of code, and they'd have to wait about 45 seconds for all the characters in that line of code to show up in the IDE. And that's a pain in the neck, first and foremost. But having that sort of friction with every line of code that you write, that's going to slow you down, obviously, but it's also going to make you very sad to actually work with the code. So there seemed to be some issues initially. But the biggest one, and I would file this under the category of unknown unknowns, which was app size. Apple had a pretty stringent 100 megabyte download limit for downloading apps over cellular data. And there was really no way to get around this. And the original plan was that they were going to ship in the same bundle. I mean, every app on the App Store is basically just a zip file. Within that bundle, they were going to ship both their old app and their new app and sort of gradually transition over. You can think of this as kind of like A/B testing. Immediately, it became apparent that that was not going to work because they were going to fly past this 100 megabyte limit if they did this. And the problem here is that, as it just so happens, Swift code is bigger in terms of binary executable size than Objective-C. A full discussion of why is beyond the scope of this presentation, but they needed to figure something out. And so they went to the CEO, and the CEO said, yeah, let's do it. And this was called the YOLO approach. You only live once, if you're not familiar. So right away, they are losing their fallback of the previous application, and everybody's getting the new app the instant the update hits, or when each user hits update. And they saw, even more concerning, that even once they got rid of the old application, their code was growing at about a megabyte every week. And so they had a very clear indication of when they were going to go over this 100 megabyte download limit. And so they had to go through and do some pretty crazy stuff. Again, very technical. It goes well beyond the scope of this talk. But they were converting things from structs back to classes, because it turns out in Swift, classes are just a little bit smaller than structs. I mean, they were really spending a lot of time shifting deck chairs around to keep under the size limit. And this ended up creating, sort of competing factions. There was the Swift faction, which had obviously won to that point, and then this other faction that said, hey, let's just go back to Objective-C. And so they did a little test to see what the business impact is of an app that is too big to download over cellular. And you can imagine if people are downloading Uber for the first time, it's probably because they're maybe in an unfamiliar area, they're on a street corner, they're looking for a way to get from point A to point B, they're probably not on Wi-Fi. And this actually was borne out by the data because they saw that the indications that they had were that the impact on their bottom line would be orders of magnitude than the entire cost of the rewrite. And this is a year-long rewrite that undoubtedly cost millions of dollars. So they absolutely could not go over this limit. And they ended up doing this crazy simulated annealing algorithm for compiler passes that shifted the way that the optimizations that the compiler was doing to their code around so that they would end up with the smallest possible outcome. And if you're a developer, or if you worked on Swift at the time, you might be sweating a little bit, because that's the sort of thing that is going to introduce weird runtime behavior that is just going to be very troublesome to troubleshoot. And when the possibility that, hey, maybe we shouldn't do this came up within Uber, the developers who went on to write, there's a few blog posts about this that are very, very interesting. The developer was told by basically his VP and everybody else up the chain, they were all going to pack their bags because this had to happen or they were out of a job. So they did actually get it out the door, and it mostly worked. There were a few bugs that they had to hotfix after release, but their goal was to have a stable version of the app in the App Store for the Christmas App Store freeze. Apple freezes the App Store during Christmas, so you can't publish new updates. And they did make it, but what did it cost? Well, they were working easily 80-hour weeks. They flew multiple teams in from different countries to come work in San Francisco for the duration of this. They were dealing with 2 a.m. emergencies all the time. And as you can imagine, a number of people just completely burned out. They worked on this project and then quit Uber immediately after, or they quit during. It was noted that several people quit even before getting their next bonus, which would have been in March. So, from Christmas to March, they couldn't even stick around for 3 more months. They were just burnt out. And my take on this is that no app is worth a human burning out or having their mental health impacted. Software is just not that important, as it turns out. So this is bad. Also, they were reassigning their new hires. They were bringing on people who said, oh yeah, I know Java, I know Android, I want to work on the Android app. And they were like, well, what if we actually had you work on Swift and iOS? And that's very different. There's some comparable strategies, but a very different development paradigm. And I don't know about you, but if I'm hiring developers, I'm bringing them on for a specific task and I want them to do that task. And so shifting developers around like this is just kind of a huge waste of money. And this introduced some issues with their DevOps. They had a test suite, but it took hours to run. So they ended up removing it at a certain point just so they could land code. And of course, when they re-added the test suite, guess what happened? A bunch of regressions had migrated into or snuck their way into the code base while the test suite was disabled. So they're hitting a lot of issues with their pipeline and trying to work around it, but just paying the price. And they got very, very close to going over that limit. They only really were saved by the fact that Apple kept increasing the mobile data download limit. I believe first 150 megabytes and then 200, and then I think eventually they removed it. Probably in large part because Uber was a huge success story for the App Store. And they're also at the same time they're not only changing the language they're using to write this application, they're also making a bunch of changes to the UX at the same time. So it's not like you could exactly use the same integration tests on the old code and the new code. It wouldn't really work because it's a completely different UX. And yeah, right after they launched, like I said, they were seeing weird error messages about payments and compliance and stuff. And my understanding is that a bulk of the code that the Uber app contains is regulatory code, because they're subject to different regulations at different markets that they operate. And so tracking this sort of thing down was very, very tricky. And I didn't see this explicitly mentioned in any of the write-ups, but obviously, if you're asking people to work 80 hours a week, they are adding technical debt. I would just assume every minute you're working over 40 hours a week, I just assume that person is adding technical debt. Maybe a few hours here and there is not so bad, but if you're working 80-hour weeks, I'm sorry, but you're just not producing your highest quality code. It's just not possible. And we're going to get back to some of those points in later sections. But now let's talk about our second case study, Java psychic signatures. This is a new one. I wanted to talk about something that happened a little more recently. And then this one I think is really interesting. So there's a great write-up that Neil Madden did. He works at a company called ForgeRock about this, and they found this bug. And there's a lot of technical stuff we could go into here, but I'm not going to because it's boring and beyond the scope of the talk. But basically, for elliptic curve digital signatures, you have two variables that are initialized, R and S. You have a public key and a message hash and stuff like that. But we're really going to focus on these two variables, R and S. And R and S get used a lot in multiplication. That's a big part of multiplying numbers to derive keys, things like that. Again, all part of cryptography. Nobody really knows how cryptography works. So Java, the JDK development team has a ticket to port their curve verification from C++ to Java. And this ticket is it's publicly available. And you can look at the description on it. It says, lessen our dependency on the old native implementation. There might be good reasons for that. There could be good benefits to lessening that dependency. But this description alone, to me, does not justify rewriting cryptography, something that is extremely difficult to get correct. And so if I have battle-tested cryptography code, personally, I'm not swayed by this argument that we should get it out of C++ and it back into Java, or into Java in the first place. So they do this rewrite, and they do have tests, but there is no check to verify that R and S are non-zero. So multiplication, you multiply something times 0, it's 0. And so a lot of things that would check to see if R and S are properly initialized, if they're properly, if they're going to verify the signature, if there's 0, a lot of those checks just don't work. And so if you provide a signature on your, encrypted message or what have you, and R and S are both 0, Java's like, yeah, looks good to me. And a big part of this was their test suite. They were not using, I should have looked up how to pronounce this, they were not using Project Wyckoproof, which is this Google project to create standardized tests for the most common cryptography issues, one of those being the initialization of R and S to non-zero values. As soon as Neil Madden tested this, it immediately failed. So what happened here? Well, Java, their implementation of ECDSA was vulnerable for 2 years, and nobody caught it. This impacted Java's 15 through 17, which I guess, a lot of people probably got saved by this a little bit because apparently most of the industry is still on Java 8 and 11. So a lot of people just dodged the bullet here. But having seen this now, my thought is, well, Java's 15 through 17, they assuredly have other cryptography bugs, maybe not as severe as this, but my confidence in that cryptography library as a whole is shaken. And as the Java company is more than happy to remind us, billions of devices run Java. It's all over the place. So the scope of an issue is massive. And ECDSA in particular is very important for two-factor authentication. Two-factor authentication is, you could argue, the last line of defense in authentication. And so it's something you really want to get right. And having ECDSA just say like, oh yeah, 0 and 0 looks good to me, this is a good signature, that's a problem. And so they released a critical patch update release. This was 2 months ago now. And it was 520 security patches across 175 products. I would never want to have to push out a critical patch update that has that much stuff in it. That's a huge surface area. And it's not even the first time Java has had this problem. Kind of as an interesting aside, in 2013, there was this issue with secure random, where secure random was not as random as you might like. And so this impacted a lot of Bitcoin wallets at the time. And I found this really interesting. I wanted to actually go and look at the code before and after. And the exact technical details are probably beyond the scope. But on the left here, we have the code that was written before. This is in C++. And look at this comment. Look at this beautiful comment. This is one of my favorite comments of all time. It says the spec, the section, the steps from the spec that's happening, and just a little bit of a description. Verify that R, it has to be less than N as well, but it's also greater than 0, and then S is also greater than 0 and less than N. That's a fantastic comment. I immediately know what's happening here, and I can try to struggle with my memories of what C++ is and how it works to figure out exactly what's going on inside of this if statement. After, that comment is gone. And you can still see there's the same check, if, RB signum, whatever, if it's equal to 0, we return false. I think you could probably make the case that maybe return false is less informative than, setting an error saying specifically this is a bad signature. I know goto is considered harmful or whatever, but I think there's some value to having that. Whereas on the right, that indication of what exactly is wrong is gone. It's just returning false. So, code upstream of this might handle that, but that comment is just gone, just obliterated. That's a real shame. Because it's a great comment. It's a fantastic comment. Okay. So I'm going to try to lean on my MBA experience here and talk a little bit more about the business impacts of a rewrite by comparing two companies that have done multiple high visibility rewrites. That's Basecamp and Wunderlist. So let's talk about Basecamp. If you're familiar, they're sort of a project management company, originally 37 Signals. They renamed their company to Basecamp to match the name of their product. And the way that this is described is when Basecamp 1 was in operation for a few years, they started to feel a lack of enthusiasm. And they weren't actually dogfooding. They weren't using this project management tool internally. So that's kind of how they were feeling. And they had a very, very large customer base, and I'm sure they still do, which means that anytime you make a change of any kind to the application, you are impacting dozens, hundreds, maybe thousands of people's daily workflow that they depend on. And one of the most frustrating things that happens to me, a bit of a pet peeve, is there's something I need to use for work and they move a button or they remove an option, or they change a dialogue or whatever. It's like, I just want to get my work done. Why are you shifting this stuff around? And so they felt kind of locked in. So what did they do? They went back to the drawing board entirely and created a whole new product with the new solutions for the problems that their customers had indicated over the course of Basecamp's original time. And that is, I think, very, very interesting. I think you could really make the case for a rewrite being justified in the situation where you have new ideas about the sort of problems your customers are facing. But what do you do with the clients that you already have? Well, they didn't shut down Basecamp Classic, and they just let people continue to use it. The downside to there internally is they still have to maintain Basecamp Classic. You can encourage customers to migrate, but not make them. And all your new customers come on board with Basecamp 2. And the justification here, I think, is very interesting. They wanted to try to avoid putting customers back into buying mode. If your primary product for managing your day-to-day business is all of a sudden going to change, now it's like, well, do we want to stay with this or do we want to switch over to another product? They wanted to avoid having their customers think about that, obviously. And then they ended up repeating this process just a few years later for Basecamp 3. So now we're going to talk a little bit about Wunderlist. So Wunderlist, I don't know if there are any Wunderlist users, former Wunderlist users in the area. I'm one of them. I was actually a huge fan of it right out the gate. And I found out later on, very recently, actually, I found out that it was originally written in Accelerator Titanium. if you've written anything in Accelerator Titanium, you might understand why a rewrite might be desired. They had very, very quick initial growth. The number of users that they had grew faster than Twitter or Evernote. They reached 1 million users far before those companies ever did in relative timelines. And this was originally, Wunderlist was originally part of a broader suite of tools, and a to-do list was just an easy part to kind of roll out first and gain interest. Well, they ended up abandoning WonderKit entirely just to focus on Wunderlist. So they have millions of users, but now without the upsell to WonderKit, they have no revenue model, and their growth rate starts to slow down. And customers are bringing up usability concerns. So that's when they decide Wunderlist 2 is the right move here, and they are actually going to write it natively for every platform that they support. And that is a lot of work and a lot of engineers. I believe at the time they supported, iOS, Android, probably Windows and Mac, and maybe Linux. That's a lot of native code, and that's a lot of code that may or may not be able to get shared, as opposed to Accelerator Titanium for, it has some drawbacks, but the code is reusable across multiple platforms. Well, how does this rollout go? The application is down for 48 hours after launch. That's horrible. But 48 hours of downtime immediately after launch, because as soon as they got any load on the system, it started to catch fire. They had a test suite, but it took 10 minutes to run. It was very slow, and it was very brittle. They spent most of their time fixing the test suite. And so the way that it was described is that internally they felt deployment was scary. Going into and subsequent from the Wunderlist 2 release, they were just scared to push out new code, and that's not a good place to be in, because that's how you get new features to your customers. So what they ended up doing actually is rewriting the application again in Wunderlist 3, and a big part of that rewrite was real-time synchronization of, again, to-do lists. So what are the relative fallouts of these two approaches? With Basecamp, their new customers get the latest version, and then their claim is that existing customers can stay on Basecamp Classic until the end of the internet. It's a web-based technology, so as long as the web still exists, Basecamp Classic should work. Today, Basecamp is still around. There are some cultural issues, which I'm not going to go into, but I just point that out to say that just because your approach to getting code out may or may not be good, there are other components to maintaining a good company. Well, what happened to Wunderlist? Well, they got bought by Microsoft. And Microsoft, as they are wont to do, immediately decided to use the talent behind Wunderlist to write a Microsoft app as part of their app suite, MS To Do. And after this was announced, they said, well, we're going to shut down Wunderlist, of course, because they want everybody to be on MS To Do. And one of the co-founders of Wunderlist actually offered to buy Wunderlist back after they had sold, because they didn't want to shut it down. But of course, Microsoft did. Internally, they had to do some, I think, Microsoft-specific work. They had to port it from AWS to Azure. They had to integrate it with Exchange and Cortana. And at the end of the day, Wunderlist is gone, leaving existing customers, myself included, pretty unhappy. That's not a great thing to do to your customer base. Now, we're about halfway through here, and you've all been a great audience. So if I attended a conference hosted by a company called Corgi Bytes, and there were no corgis on screen at any point, I would be furious. I'd want my money back. So here are some corgis. These are my corgis growing up, April, Tyler, and Tug. We're just going to enjoy their calming energy for a moment here before we move on. They're all good dogs. Okay, so why do people rewrite? Why do these happen? Why do these rewrites happen? A lot of the time, it reminds me of this moment from Arrested Development, which I've sort of adapted here. Greenfield development to replace a legacy app. Did it ever work? It never does. I mean, people somehow might delude themselves into thinking, but it might work for us. And that's very much the approach I see a lot of times, where people are aware of the consequences. Joel on Software once said that this was like the biggest mistake you could possibly make, is rewriting your code. So why do people do it? Why does it happen anyways? Well, first and foremost, I think a big problem is that code is hard to read. Code is easy to write, but hard to read. I work with a lot of legacy code at Corgi Bytes, and it's a different tool set. It's a different way of looking at things to try to understand, okay, well, what's the context this code is running in? What is happening? What was the context at the time the code was written? And it takes a while to parse out the actual behavior of code in the context of a broader application. You can look at a snip and kind of figure it out, but it's very different when you're looking at millions of lines of code. And also, perception is reality. This was something that was mentioned at Wunderlist and was mentioned at Uber. They felt their code was old and hard to work with. And so guess what? Their code is old and hard to work with. It doesn't really matter if there's any sort of objective measure of whether code is hard to work with. If everybody at the company feels that way, it is. There is also sort of an enthusiasm issue. If you are going to work every day and dreading writing your app in COBOL, that is going to impact you. And a lot of times what developers want to do is play with the latest and greatest tools, whether that's Rust or Go or what have you. There are newer tools that people want to work with. And so being stuck with that old stuff can drain some of your enthusiasm. Also, you can see in some cases that the initial design just kind of fell short. This was a problem with, Wunderlist 2 going into Wunderlist 3 is that the design didn't scale very well. Or with Uber, I would imagine almost every startup company, the code that they write for the initial thing, the thing that gets them their, millions of dollars of free VC money from Silicon Valley, that code is going to not necessarily address every single problem. It's going to, get off the ground. It's going to do the things that the code's supposed to do, but it might not be pretty to look at. And so you might have to address some technical debt there. In some cases, the technology that's underpinning your code might stop being supported. You could imagine, for example, if you've got an app running in VBScript, you want to get off VBScript because VBScript is not officially supported anymore. You could also see this as a way to sort of default in your technical debt. You can just kind of say like, oh, we're going to declare bankruptcy here. And, all the technical debt that we've accumulated will be wiped off the slate and we just start fresh, which sounds appealing, but you're still going to accumulate technical debt. I'm sorry, but entropy exists. So it's going to be an issue one way or the other over a long enough timeline. You can see this as a way to attract new customers. I think this argument is a little bit dubious. This is kind of what Uber was going for. I think their front end definitely attracted new customers. It was flashier, it was cleaner, it was more modern. But I don't think the average Uber rider cares if the application is written in Objective-C or Swift, and I doubt they even know what that means. You can also use this as an opportunity to respond to changes in the market conditions. Maybe your competitors are introducing new features, or there's a new standard in your industry that you just don't have. Rewriting your code can be a way to do that. I would argue that you could also extend your existing code to do that. And if it can't be extended in that way, you could re-architect some things to make it so that it does. But in terms of, maybe a seemingly easier way to respond to the changes that are going on in any industry, rewriting your app from scratch could be a way to do that. Performance, I don't see this argument that much, but there are cases certainly where just in terms of wall clock time, number of cycles, if your application is slow, if it feels slow to the end user, you might want to rewrite it in order to get more performant code. There's also this case of combinatorial state explosion. You might think, oh, this application is going to be so simple. You launch to your customers, then it's like, okay, well, we've got customers in Europe and they have different, GDPR regulations. So we have to, that's one way the code is bisected. And then, there's all these combinations of different states the application could be in. And the more of those you get, the harder it's going to be to troubleshoot. There's more states, more complexity, tougher to understand. And rewriting can be seen as a way to kind of clean the slate on that. And then finally, and maybe even most often, it's just hubris, just plain old-fashioned hubris. People who think like, oh, those developers that wrote the application originally, they don't know what they were doing. I do. And so I can rewrite the application and solve every single problem that existed before. Yeah, I'm sure you can solve some problems, but there's a lot of stuff in that code that you may not understand, which is why I think legacy code has intrinsic value. And I'm going to pause dramatically because I'm very thirsty. Okay. So what do I mean here when I say legacy code has intrinsic value? Well, the legacy code that you already have is an authoritative source of truth. If that is code that is running in production and you have some users, your users are validating that code all the time. They're verifying that it has the correct logic. And all that logic, all that business logic that is so vital for your role in your industry, it's all there. And like I said, reading code is harder than writing code. So reading the code, you might be like, oh, okay, this is just, an HTML form or whatever. You might actually find out like there's a ton of special cases that you didn't even consider. And all of those special cases, they might make the code look messy. And, maybe there's a refactoring to be done there to make it more evident. But that logic already exists and is already being handled by your current application. If you have it, Git history or any version control history can be very, very valuable. I know all the time, I'm like, oh, this method is bad, this class is stupid, why did anybody write it like this? Go ahead and check the Git blame. Says Steve Richey, that's unfortunate. But that information is very, very valuable. If that's tied into your project management tools or whatever, you can see tickets, you can see issues. There's a lot of information that Git history, and you can at the very least see when a commit is made, what are the other commits being made over this time, what's the description of the commit, what other files that's changed as part of a merge request. All very, very useful information to have. Comments, like I pointed out with the Java ECDSA example, comments can contain very, very useful information. I'm sure you're all familiar, but a good comment explains why a code is a certain way, not necessarily what it does. The code explains what it does, but code can't tell you why. It's also a great framework or great foundation for writing integration tests. If you've got an existing application, even if the code's a nightmare, don't even worry about the code. Write tests, and then if you want to refactor or rewrite, you've got all these great tests to verify that the rewrite or the refactor didn't change anything, didn't break anything. And please write tests. Please write tests. Everybody should be writing tests. We should all write more tests. Tests are cool. So, and you also might see in your code that there are some seemingly messy code. This is like, oh, this is spaghetti code or whatever. It might be like that because there are just a ton of edge cases, and maybe it's not handled elegantly. But if you're just trying a clean slate rewrite, you might miss a lot of those edge cases. Edge cases are very, very easy to miss during rewrites and even refactoring. So, okay, I'm going to assume at this point that you're at least a little bit convinced of the value of legacy code. I mean, you're at MenderCon, you're on board. But what are some approaches? What are some tools we can use to make sure that our refactoring efforts don't fall into some of the traps that we saw before? Because, a big refactor, how distinct is that really from a rewrite? Well, I want to talk a little bit about this term of logical equivalence. I'm sure you're familiar, but basically you can express something in multiple ways and it has the same meaning. And that's the underpinning of refactoring, is that you are expressing some of the same ideas, but you're using different code to do it. And this can be very, very literal. De Morgan's law is an example of this, where not A and not B is equivalent to not A or B. And so, apologies to Augustus De Morgan, but I can say I am not bald and not bespectacled. And the equivalent statement would be I am not bald or bespectacled. Either way, it indicates that I have my hair and I don't wear glasses. I wear contacts. But the meaning is the same, despite the fact that these phrases are different. Well, how does that tie into computer science? Well, here we've got an example of some code. On the left, it's a very simple function that just does what De Morgan's law says. It takes two Booleans, it returns not A and not B. And you can see on the right, this is via godbolt.org, which is a fantastic resource if you're curious, kind of digging into the machine code that gets actually generated from your more or less human readable code. And the exact details of what's happening on the right-hand screen here are not important. But if we were to refactor this to not A or B, so we're applying De Morgan's law here, we can see that the code is identical. I mean, I can flip back and forth here, and you can see the code is exactly the same. So it is possible to rewrite your code, refactor your code, and create code that the compiler can recognize as identical. And the scope of most used code today that you would write, thousands or millions of lines of code, that scope doesn't necessarily allow us to do things like verify the generated machine code is identical, but you can take this idea and use this idea to think about your code. Take your code, break it into small testable components that you can validate are actually equivalent, whether that be through tests or even manual tests if you actually absolutely have to. And you can do this rewrite with confidence that the stuff that you're rewriting is fundamentally identical. When I say small testable components, this could be a lot of things. It could be a package, it could be a module, but it might just be a web page, it might be a function, it might be a class. Don't feel limited if your code is not super well structured. So tests, please write tests. Good tests will validate that the behavior was identical before and after. And you can think about code coverage here. You actually want to verify that you are exercising all of the code that you have. But an interesting development in testing that I'm a big fan of, and I actually want to work with more, is property-based testing. So instead of trying to just sit around and think about every possible state your code could be in, property-based testing is feeding a bunch of different states into your test and validating that they all perform as you would expect. It's a very easy way to take a single test and essentially it's fuzzing, right? It's taking a ton of data and feeding it into your test and validating, yes, this is going to work across a wide array of conditions. A key component of equivalence is that you want things to be as similar as possible. So when you're doing a rewrite, do not add features. If you're going to do a rewrite of some kind, try to do sort of an apples to apples replacement. Try to keep the features and the interface, whether that interface is a literal user interface or something more like a CLI or an API or something. Don't add features during the rewrite. Save those for after. Rewrite the code, get it into a good stable condition where it's equivalent because you validated it with tests and other methods. And now you can start to add features once you've created whatever architectural change you think is necessary for that to happen. And as you're doing this rewrite, bring in the subject matter experts. Have them review the code. We do a lot of consulting. And so what I will usually do when I'm helping someone refactor code is say, okay, I've done the refactoring. You're the expert. You wrote this or you were around when it was written. Tell me if this is, to your mind, equivalent. Now, ideally, you have tests and stuff to back that up, but the subject matter experts, they know what they're talking about and leverage that information. Something that I'm very interested in, and I think this is going to be a growth area over the next decade, is formal verification. Using mathematical proofs to verify that, yes, this code is going to behave exactly in this way 100% of the time, because computers are just, math machines, and math can prove things with 100% certainty. So if you can prove that your code is going to run a certain way with 100% certainty, you don't need tests. You've formally verified the behavior of this even before you run it. So this is a very intensive and sort of an expensive operation to do right now. Again, I think that's going to change in the next decade. But if you've got super vital code that absolutely has to run the correct way every single time, consider formal verification. It's used a lot for cryptography libraries now. It's very slow. I believe in one of the most famous examples, they were writing like one line of C code a day. But the end result is something that you absolutely understand. And this is, I think, a great approach if you've got very, very important code. Okay, so that's everything I wanted to cover. I really appreciate everybody attending. I appreciate Corgi Bytes for letting me yammer on for nearly an hour here. And I am going to open the floor for questions. So if you have a question, please drop it in the comments. Robbie Russell, I am going to listen to that podcast that you mentioned. That does seem interesting. Witch proof? I would like all of my code to be witch proof. Actually, if my code could be resilient to witch based attacks, that would be, I think helpful. Is Swift any better now? I like Swift. I think that the syntax is pretty good. Oh, thank you. The syntax is good. I like the general approach to it. They're doing some interesting things with dynamism for like Swift UI that I feel is not necessarily what I would want out of Swift. What I really like about Swift is it lets you create really like immutable code that makes it much more easy to reason about. I like Swift. I like working in Swift. Right now, I think probably the only practical application for Swift is for iOS applications. I would definitely not recommend that you start writing a new iOS application in Objective-C in 2022. But Swift, I think, is pretty good. Swift UI seems like maybe not ready for prime time just yet, but I like Swift a lot. It's really good for writing like little scripts. You know, it's kind of a pain in the neck to get running on Windows, unfortunately. But if you want to write a little script in Swift, and that'd probably be a good way to start, because it has good guard let statements and things like that let you bail if things are not going right. Oh, this is a really good question. Okay, I'm going to try to figure out how to share. Okay. I got a guardian angel waiting in the wings. So one of the complaints that Tiago here, I hope, hears about working on legacy code is it's hard to hire people. I definitely agree. I think that going forward, there are not a lot of new COBOL developers being born. But as it turns out, a lot of I believe the banking industry is written in COBOL and like Fortran and stuff like this, languages that most people are not necessarily learning actively. You might cover them in a computer science course, but they are certainly less common now. And I think that we are going to have a reckoning there. I think that we are going to, honestly, I think working with legacy code is a bit of a growth industry because of this, because there's a lot of legacy code that is very, very vital and not a lot of people that understand how it works. And that code's not going to go away anytime soon. It's not going to be any less relevant. So we certainly need to think about that going forward. What can we do about it? We can hire Corgi Bytes to take care of the problem for you. No. Yeah, I think it's an education issue. I think we need to make resources more available for people to work with legacy code. I think we need to change some of the stigmas. The idea of move fast and break things. I think we need people that move slow and fix things as well to kind of tidy up behind the people that are going fast and breaking things as they move along. And yeah, I don't know. I think that's an ongoing discussion. That's a good question. I'm not really sure what the solution is, but definitely education is a big part of it. All right, well, I'm going to go ahead and call it there. Again, thank you very much for attending and letting me yell at you for way too long about the things that I think are interesting. And thank you again to Corgi Bytes for having me. MenderCon has been really, really enjoyable so far. So thank you very much for letting me be here. And I'm going to try to figure out how to stop this presentation, but I cannot guarantee anything. Okay. Goodbye.